video, we will talk about waves. We will start by discussing the different types of waves, namely electromagnetic versus mechanical waves. We will also describe the differences between longitudinal and transverse waves. We will then move on to provide an explanation and debriefing about the different notions and concepts of waves, starting with the characteristics such as the amplitude of a wave, the period, the wavelength, the displacement, and the frequency of a wave. We'll then provide some formulas governing waves, such as how to find the velocity from the wavelength and the period, or the wavelength and the frequency, and then give the relation between the frequency and the period of a wave. We will wrap up the video with some practical applications. So we will start by discussing the differences between electromagnetic and mechanical waves. As the name implies, electromagnetic waves are a combination of electric and magnetic signals. Electromagnetic waves do not need any medium to travel, meaning that they can travel in free space or in vacuum. And electromagnetic waves move at the speed of light, which is 3 times 10 to the power 8 meters per second, or 300,000 kilometers per hour. Some examples of electromagnetic waves include the electromagnetic spectrum. We start with radio waves, such as the waves that we receive in regular radio systems, microwaves, which are waves that are used in mobile communications, infrared waves, or also known as heat waves or heat radiation, visible light waves, ultraviolet waves, X-rays, and finally the most powerful, which are gamma rays. On the other hand, mechanical waves do require a medium to travel, and that's why we do not see sound waves traveling in space or in vacuum, because they need a medium to travel through. And usually those waves, the mechanical waves, travel at speeds much less than the speed of light. Some examples of mechanical waves include sound waves and seismic waves. Waves can be classified as longitudinal or transverse waves. Starting with longitudinal waves, displacement in such types of waves is along the direction of motion, whereas on the other hand, displacement in transverse waves is perpendicular to the direction of motion. Examples of longitudinal waves include waves on a spring, whereas examples of transverse waves include electromagnetic waves, which we just discussed, ocean waves, or waves on a string. In this figure, we can see the wave formed on a spring. As we can see, displacement, which is represented by the compressions moving sideways from left to right or vice versa, is along the direction of motion. Whereas in this next figure, the displacement, which is the vertical arrow shown in the figure, is perpendicular to the direction of motion, which is going in this figure from left to right. Now we will provide some main characteristics of waves. We will start by giving a very important notion regarding waves, which is that waves are able to displace energy but not matter. So energy is transferred by a wave from one point to the other, whereas matter is not transferred by waves. That's why when we try to create a wave on a rope, energy is felt on the other side, whereas the actual material of the rope oscillates up and down but does not transfer horizontally. On this figure, we will explain some main characteristics of waves, starting with the direction of motion of a wave. It's in fact the direction of motion of energy transferred by the wave. In this figure, it is horizontal from left to right. Next, we will talk about the amplitude, and it's the distance between the highest point on the wave till the axis of the wave, or what we call the crest of the wave till the axis of the wave, and the amplitude is given in meters. Next, we talk about the period. It's given in seconds, and it's the time between two crests or two maxima on the wave. And regarding the wavelength, it's also measured in meters, and it's the distance between two crests of the wave. Now we will provide a very essential formula that allows calculating the velocity of a wave. As we know, the velocity is usually the distance divided by time. So when it comes to waves, we can say that the velocity is equal to the wavelength of the wave in meters divided by the period in seconds. Another essential formula to keep in mind is that the frequency of a wave is equal to 1 divided by the period, noting that the frequency is in hertz. Now, using this frequency formula and plugging it into the velocity formula, we can deduce that the velocity is also given by the wavelength multiplied by the frequency. The velocity is always in meters per second, which is the SI unit of velocity. We will now wrap up this video by providing a practical application which will help us better understand the main topics provided. A radio wave received on a radio station has a frequency of 104 MHz and moves at the speed of light, which is 3 times 10 to the power 8 meters per second. A. What is the type of this wave? B. Calculate the period of the wave. And C. Calculate the wavelength of the wave. Starting with the type of the wave, and since this is a radio wave, then it's electromagnetic. And as we said earlier, all electromagnetic waves are transverse. Therefore, this wave is an electromagnetic transverse wave. Now, regarding the period, we saw earlier that the frequency is 1 over the period. Therefore, we can rearrange this formula to say that the period t is 1 over the frequency. So t is equal to 1 over f. So it's equal to 1 divided by 104 times 10 to the power 6, which is the 104 megahertz. And therefore, we say that the period is equal to 9.61 nanoseconds, noting that nano refers to 10 to the power -9. Finally, regarding the wavelength, we will use the velocity formula that we gave earlier. So the velocity is the wavelength times the frequency. We can rearrange this formula to say that the wavelength is the velocity divided by the frequency. So it's 3 times 10 to the power 8, which is the speed of light, divided by the given frequency, 104 times 10 to the 6. So we deduce that the wavelength lambda is equal to 2.89 meters.